Okay, good.
To give you a countdown or something, or
No, you never know when these things.
yeah, it hasn't refreshed on my page yet, but it will.
Okay. People may be hearing this banter, but that's okay. I just want to make sure that we are actually live.
There we are.
I think we're going. Real
There.
good.
I
Okay.
just muted it, so good.
All right. I'm Barry Bird. Welcome to this session in the J Champions Conference. I'm here to introduce you to Ken Cousin. He'll be telling you about himself, talking to you, saying exciting things, and I'll leave it now to Ken.
Oh, thank you very much, Barry. Welcome, everybody. I'm glad that so many of you have been able to make it here. This has really been a fun conference, so I'm glad so many of you are around. I see that we do have confirmation that you're hearing us okay. I'm keeping a basic eye on the chat, but really it's Barry who's going to monitor the chat mostly and let me know if you have questions, comments, words of wisdom, or have heard any really good jokes lately. In the meantime, let me tell you, first of all, I do have some slides for this, and I'm going to use the slides, but I also am going to spend a lot of time in the code. And we're going to talk about all three languages, Groovy and Java and Kotlin, both with the comparison and what they do similarly and what they do differently in terms of functional programming. So feel free to put your questions or comments. Wow, we have somebody from Morocco. Wonderful. Thank you for coming. And from Colombia as well. Excellent. Any rate, feel free to put your comments and everything in the chat. And as I say, Barry will keep an eye on it if I miss it. And then we'll try to deal with as much as we can. Now, this is my contact information. You don't have to pay much attention to this, except as Barry said, my name's Ken Cousin. My email address is there, homepage, blog, Twitter handle. I also write a free, emphasis on free, weekly newsletter called Tales from the Jar Side, which is hosted on Substack. You can take a look. You can look at the whole archive if you want. The books here are just to illustrate that I've worked in not just Java, but also Groovy and Kotlin. I've worked with Gradle. My most recent book is non-technical. It's called Help Your Boss Help You, which is about how to manage your manager to get what you want out of your job and your career. All right, now the GitHub repository that's going to have all the code in it is hosted right here. So I think, let me see if I can do this. I'm going to try to paste that into the chat as well. Show chat. And if I can't figure it out, oh, no, there it is. Okay, so that is the GitHub repository. Now, that repository has a copy of these slides in it, although it's a slightly earlier copy. I haven't updated it for the most recent contact information, but you can grab this too, and after the presentation, I'll take these slides as a PDF and add it there. So it uses the latest versions of Groovy and Java. Now, Groovy and Kotlin, rather. It says only Java 11, but I'm honestly over the holidays, I got one of those new M1 Max with the Apple Silicon, and it turns out that the default Java you get with those when you start installing things built for the M1 Silicon is 17. So I'm actually going to use 17 today, but I'm not using any features that go beyond 11 in the Java portion. Now, speaking of that GitHub repository, oh, somebody from Turkey, welcome, and Chicago too, and oh, MIT, how about that? Any rate, here is the GitHub repository opened in IntelliJ Ultimate. And what you could see is I have a source main Groovy, I have a source main Java, and I have a source main Kotlin. So I'm freely using, and the same thing for tests, by the way, Groovy, Java, and Kotlin. I'm mixing the tests in all languages. And here's my build file just to show you that, in fact, I am using the Java plugin, the Groovy plugin, and the Kotlin plugin all inside here. Now, this tool chain is making it automatically use Java 17 when I run the code. If you clone the repo and you need to run anything and you don't have 17, I think you could just delete that block and I think everything will be fine. I do think I'm using things from up to Java 11, but I don't think I'm using anything beyond that. The rest of this is just showing these are the Groovy dependencies. Here's the Kotlin dependencies. I've got Google's JSON in there, some coroutine stuff. And then the testing frameworks are Spock from the Groovy world, JUnit Jupyter, and Vintage Engine. So there's really nothing that's all that unusual. And there's my versions again. There's the Groovy version and the Kotlin version and Spock, etc. Okay, so now let me go to the information itself. Now, Java, Groovy, and Kotlin are all languages that compile to bytecodes on the JVM. I've got somebody from Amsterdam. Oh, we got a Jarhead. I'm sorry. The people who read my newsletter, Tales from the Jar Side, are affectionately known as Jarheads, at least until I get pushback on that, which so far so good. Wow, thank you so much for coming. I appreciate that. How about that? You got the popcorn. Excellent. Auf Deutsch, ja, in Deutschland. At any rate, my point was Java, Groovy, and Kotlin all compile to bytecodes on the JVM. And none of them are functional languages. We're going to talk about functional features in all three, but they're not functional languages. What I would call them is object-oriented languages that have various degrees of functional features in them. So Java, you probably know, I'm going to go over a little bit of that, but I want to show you some of the Groovy functional features and the Kotlin ones, and we'll see how they implemented things similarly, and maybe more importantly, how they implemented them differently. You know, what decisions did they make based on these different languages? Now, Java, of course, has literally 25 years of backward compatibility issues, but the Java functional features were really added in version 1.8. Now, by the way, the vendor I'm using for my JDK is Eclipse Temurin. So I'm using just the standard open source one. It's an open JDK build. Oh, we've got somebody from Sydney. Wonderful. And Paris, bonjour. Brazil, fantastic. Okay. Any rate, so it doesn't matter what vendor you get your JDK from. I happen to be using the one that used to be Adopt Open JDK, is now Eclipse Adoptium. And of course, the current long-term support version is 17. Now in Groovy is almost as old as Java. Groovy goes back to, you know, the early, like 2007, 8, that sort of thing. They've had their 10, 12 year anniversary, something like that. They are now an Apache project. Ooh, Tunisia. It's always great to see people from Africa in these. At any rate, Groovy became an Apache project. It didn't start that way, but it is now a top level project at Apache. Relative to some of these others, it's quite mature. I mean, it's certainly relative to Kotlin. So it has a lot of the features you want. The best part about Groovy is the syntax is very easy for Java developers to learn. And in fact, Groovy is almost never used by itself. I mean, most of the success stories for Groovy are actually combined Groovy and Java projects. They use both together. So you don't really talk about Groovy successes as much as Groovy and Java together, and I'm using that. There's a list of different frameworks and libraries that are available in the Groovy ecosystem in case you're interested. Somebody from Ottawa and from Poland. I've been to Warsaw. I haven't yet been to Krakow, but I've been to Warsaw. Of course, in the last couple of years, I haven't been anywhere, but that's a different issue. Now, Kotlin is unusual in that it is a language managed by an IDE manufacturer. It was presented by JetBrains, and it became much more popular and eventually was adopted by Google as the definitive language for Android. And if you are an Android person, then yeah, you really need to learn Kotlin. The Spring people also are very fond of Kotlin, although I don't know how many Spring people actually use it. The question will be whether it breaks out of its little niche and starts to get more market share in the wider server-side Java world. But right now, it's definitely the definitive language for Android, and it's pretty popular, and it's a general purpose programming language. It compiles to JVM bytecodes, although the JetBrains people like to push its multi-platform and multi-language capability. It can generate JavaScript, it can work with native, all that stuff. I'm not going to do any of that. I'm sticking with the JVM. Now, okay, let's start with the Java part. The functional parts in Java have to do with Lambda expressions. And a Lambda expression, of course, is just a syntax that gets assigned to a single abstract method interface. See, this is how the languages immediately start to differ. There is no class in Java or interface in Java. Oh, somebody is using Kotlin in their Spring Boot project. Excellent. At any rate, there's no class or interface in Java called Lambda. It's any interface that has only a single abstract method, and then the parameter types are inferred from the assignment, from the context there. And one of the interesting features we're going to talk about briefly is that in a Java Lambda, you can read local variables. You can see them, but you cannot modify them. They have to be what they call final or effectively final. And this is different from Groovy and Kotlin, which can both modify those local variables. One of the issues that comes up with the issue of functional programming here is the difference between lambdas and closures. And I'll be honest, wars have been started over less. So I'm not going to try to give you a definitive answer. But a closure in principle is a lambda that also works with it's closed over its execution environment. It can see variables in scope. The functions are not necessarily what the functional people will call pure functions. Montreal, wonderful. A pure function always produces the same outputs for the same inputs and has no side effects. And Java doesn't really do that. It can do that, but there's no mechanism enforcing it or anything like that. But they do make it so that if variables are in scope, you can see them, but not necessarily modify them. Now, Groovy actually has a class called closure. And Groovy closures actually have a call method. They have a variety of methods in them and allow you to do all kinds of interesting things. So differently from Java, they didn't go with the interface mechanism. They made a class called closure. And then the closure has what's called a delegate property inside it. So when you see a property or a method inside a closure, and we'll get to one shortly, how does it get resolved? How does the compiler know where to find that property of the method if they can't see it in scope? And what they do is they look at the delegate class associated with the closure, and they look for the method there. And this is also how you wind up building DSLs, domain-specific languages. It's a mechanism that Groovy uses to create a DSL. So we've got some Project Reactor people and Northern friends. Wonderful. Bonjour. Now, Groovy closures really are closures. You can access local variables and modify them. So there's no ambiguity there. You really can. And I'll show you the syntax in a moment. Now, Kotlin, I got to say, Kotlin has the feel of a bit of a, Uruguay. Wow, fantastic. Kotlin has the feel of a bit of a Frankenstein monster. Now, I mean that in a good way. What I mean is you can see in Kotlin that, they borrowed this from Groovy. They borrowed that from Kotlin. Not Kotlin. They borrowed that from Scala, for example. They borrowed this from somewhere else. You could see a lot of features that the developers saw in other languages and kind of stitched them all together. And sometimes you could see the seams, When you see Kotlin Lambda expressions, they are Groovy closures. They're just called lambdas. But the syntax is the same. The behavior is the same. Everything's the same. Like also, when we get to sequences in Kotlin, those are Java streams with the serial numbers filed off. I mean, it's the same stuff, just with a different name. So you can see in Kotlin a lot of its heritage in other languages. So this is what the data type looks like for a Kotlin Lambda. See, they didn't use classes or interfaces or anything. They said this syntax, parentheses to the left of the arrow with the input types in the parentheses, and then an arrow, and then the output type, and that is the data type of a Kotlin Lambda, interestingly enough. And of course, they, instead of having a delegate, what Groovy calls a delegate, they call a receiver. And similarly to Groovy, they can also create DSLs, domain-specific languages, using a somewhat similar mechanism. Yeah, the question there, if you could change variable values, it's not functional. Again, the definitions are going to get loose. They really are, because none of these really are functional languages. They're all adopting functional features in regular OO languages. I mean, if you want a functional language, you can go to Haskell. And Haskell on the JVM, by the way, is called Frege. Pardon me, Frege. Pardon me, somebody from Ghana. At any rate, one of the features of functional programming, I'd say goals actually, is to work with immutables as much as possible. And yeah, if you're modifying the value of variables, is it really functional? Yeah, okay, I'm not going to get into a semantic discussion. I'm more of a engineering, let's see what we have and how we use it, and then you could decide whether it should be different or what practically you can do with it. Welcome to the person from Ghana as well, by the way. So again, in Kotlin, they call them lambdas, but they are closures. You can access local variables and modify them. Now, let me give you some quick examples. I'm trying to use a convention of using red here for Java and green for Groovy and orange, I think, for Kotlin. So these are classes in the GitHub repository. Okay, that's going to get old really fast. Let's move that over here, and there we go. So if I take a look at, say, let me look at the prime checker. I'll go directly to that. So here is prime checker in the lambdas package. And let me make this full screen. So there's a Java class, and I want to tell whether a value is prime or not. It's hard to get. Yeah, we got some penguins, right? Or from McMurdo Station. I remember once in the 90s, I had an easier time emailing McMurdo Station than I did the company across the parking lot. This is in the early days of the web. Any rate, you see in Java 7, you would say, okay, if X is less than 2, I'm going to throw an illegal argument exception. And if X is 2, it's prime. And then we get this limit, the square root of the value as an integer plus 1. And then I'm just going to go through the elements here and see if X modulo that integer divides it evenly. So this is really brute force. And if it gets through all that, then it's prime. Now, this is not a functional approach at all. Here would be the functional approach to the same problem using Java streams and everything. So again, I check the input argument. Again, I need a limit. But this time, I'm going to say X equals 2 or short-circuiting or I'll use int stream with the range closed method from 2 to the limit, and then stream has a method called none match that takes a predicate and it returns true if none of the elements satisfy the predicate. So my predicate is to take every n in that range and take the X value that was passed in and go X mod n equals 0, and this would be the functional approach to solving that problem, or at least a functional approach. It's certainly not ideal for large values, but it gets you an idea of what they expect in the Java world. I can talk about other stuff, but let me move on and I'll come back to it. Now, Groovy, on the other hand, part of Groovy's problem is that they adopted functional features a little bit too early. They chose method names that are not the method names you're expecting. And I know if they had to do over, they would use map and filter and reduce. Java has methods like map and filter and reduce, and so does Kotlin. But Groovy didn't do that. And the worst one of all is for Groovy, the word map is actually the word collect. I mean, I get it. They're trying to apply a function and collecting the results. But map is what everybody's expecting, and they call it collect. And unfortunately, Java uses collect for something completely different. Now, filter is find all. I happen to like find all better than filter. I mean, how many times have you looked at a filter and say, wait a minute, filter should be removing the elements, not saying the ones that satisfy the predicate pass through this filter? You know what I mean? It's sometimes a filter, the word filter feels backwards. Whereas find all, yeah, that makes perfect sense. Find all the elements that satisfy this predicate. The weirdest one is the reduce method in Java is called inject in Groovy. I'm not sure why. Now, Kotlin has both reduce and fold, as we'll see in a minute. So let me show you the map filter reduce, and then I'll go to the prime checker in Groovy. So here is map filter reduce in Groovy. So here I have nums is a list of integers. Now, IntelliJ is showing that that's an array list, but in Groovy, you have native syntax for collections. So there's my list. And then I take the nums. And see, this is a filter. There's find all. And the syntax, note the syntax here, the entire lambda is wrapped in braces. And if you don't use an arrow, see, IntelliJ is trying to show an arrow, but if you don't put one in, the default variable name for a one argument closure is the word it. So this is like read as find all integers such that it mod 3 equals 0, and then map, this is collect, double them all. You know, that's a function to produce a new integer. And then I can do my sum in the most awkward way possible. This would be the better way. But here's an inject, which says initialize my accumulator to 0. That's also the identity value in reduce. And then here is my lambda, which is my accumulator. So evaluate this lambda, whatever this returns becomes the new value of the accumulator on the next iteration. So this is the Groovy approach to a normal filter, map, reduce. Although again, because these are integers, there's actually a sum method. Now in Java, you would have to convert this into an int stream in order to use a sum method, because stream doesn't have a sum method. How would it? But in Groovy, we have, quote, duck typing, meaning if you call sum and there's a sum method, we're good. And that's what we have. If it walks like a duck and it quacks like a duck, it might as well be a duck. And as somebody mentioned there, yeah, Ruby does the same thing. Right. Ruby is actually, that's where the term duck typing really caught on. I don't know if that's where it originated, but that's certainly, we're very popular in the Ruby community, and Groovy does a lot of that. Now, of course, we also have an each method here, and we can do this. And the reason I'm showing this, it's giving us a warning that the local variable is being reassigned. But this is what I mean by this does not have to be final or effectively final. This code would not compile in Java because I'm modifying a local variable. But in Groovy, it goes, yeah, whatever. Okay. Now, the Groovy one, primes here. Oh, did I call it prime Groovy? Yeah, prime checker Groovy. Here's the same syntax evaluated in Groovy. So when I go is prime this time, again, I check for my illegal argument exception. I get my limit. And the thing about Groovy is the last evaluated expression in a method is returned automatically. So I don't even need the keyword return. I can just say x equals 2, or, and this is a range. Again, Kotlin borrowed that hook, line, and sinker. So here's a range from 2 up to the limit, with a find method, which says return the first element that satisfies this closure. And I'm saying if none of them satisfy the closure, then the method is prime. Then the value, rather, is prime. So this is the Groovy approach to the same problem. And I do believe I have a test case. Yeah. Now, in the test case here, this is Groovy code using the Spock testing framework that tests both the Java implementation and the Groovy implementation, because there's no reason you can't. You know, you could use Groovy to test Java. You could use Java to test Groovy. In this particular one, I'm testing this PC one. The prime checker is the Java one, and this is the Groovy one. And I'm evaluating X is prime for all of them, for all the values less than 20. The prime number is less than 20. These would be the composite ones less than 20, and the illegal argument exception, which would throw an illegal argument exception for this range. So just to show you what this looks like, all the tests passed, by the way, I ran them before we started. But just to show you what the resulting thing looks like, this is all unrolled. I think in Spock, I don't even have to say unroll anymore, but you can see the individual values are showing up here. 2 is prime, 3 is prime, etc. These are not prime. And then that one throwing the illegal argument exceptions exactly as stated. Okay. Now I think, here's Kotlin. Now I have to say a couple words about Kotlin before I show you the same thing in Kotlin there. Now this example up here is a sum function. You have to use the word function in Kotlin, and the data types come after the variable, and the return type comes after the signature. This I like to call speaking Kotlin with a Java accent, because this is just Java code written in Kotlin syntax. This would be far more idiomatic. See, because this function is only a single line implementation, you can simply assign the signature to that expression, and whatever this returns is the value of the function. This mechanism of having a single expression for a function is used extensively in the Kotlin library. By the way, there's a question, is Groovy a replacement for JRuby? That'd be an interesting idea. Of course, Ruby is not compiled, so JRuby allows you to compile it and run it in bytecodes on the JVM. But I would agree that most everything you can do in Ruby, you can do in Groovy, and that might be nice. I really, it's one of my first loves. I've loved coding in Groovy, but we're looking at all three, so we'll do that. At any rate, to show you the primes one in Kotlin, I have a class called primes.kt. Now, this is a top-level function. And in fact, here I have this is what Kotlin calls an extension function. What I have done is I've taken the integer class. Now they call it int in Kotlin. And I've added an isPrime method to it. And notice how I'm able to write this as a single line expression. This is the value that the integer, that's the integer I'm invoking isPrime on. It's referred to as this. So it's either 2 or here. Now that those less than or equal signs are not in there. That IntelliJ is showing that. I have 2 ... ceiling of the square root of converting it to double and then back to an int. It's a mess. I mean, because you can't just cast an int to double in Kotlin because they're classes. Like you couldn't assign an integer to a double capital I, capital D in Java either. You'd have to convert. Now notice these are top level functions in the math library, and you could import them as such. Think of it like Java's static imports. Same idea. So I take the square root of the double. See, the square root function requires a double. So I convert the into a double, take the square root, get the ceiling, round it up, convert it back to an int, and then my int range is 2 up to there. And then they have a none function instead of, the Java one. And there's my lambda again to see if the divisor equals 0. And I think I have a test for this somewhere. I have one, and I forget what I called it. Probably this one. Yeah, and this is actually, this is Kotlin tests to test all of these, and I could check that all the numbers are there. In fact, this is just a JUnit 5 test that happens to be written in Kotlin. So I'm really using Kotlin to use a Java library, in this case JUnit 5, to test the implementation. Okay, I got to move on to things that are more advanced than this, but let me at least take a moment to give you the prime number joke. So real quick, you can reuse this. True, or it's a one question math test. Prove or disprove that all the odd numbers are prime. So a mathematician goes, well, 3 is prime and 5 is prime, and therefore by induction, all odd numbers are prime. So more math you know, the funnier that one is. The physicist goes, 3 is prime, 5 is prime, 7 is prime. Oh, shoot, 9. That could be experimental error. 11 is prime, 13 is prime, The engineer goes, 3 is prime, 5 is prime, 7 is prime, 9 is prime, 11 is prime, 13 is prime. The computer scientist goes, 3 is prime, 5 is prime, 5 is prime, 5 is prime, 5 is prime. Ha, ha, ha. Infinite loop. And then, of course, the good one is the manager who goes, 2 is prime, 4 is prime, 6 is prime. At any rate, feel free to reuse. Okay, now back to here. Now, again, Java streams are lazy. So they decided deliberately to add a layer of indirection, right? All problems in computer science are solved by adding a layer of indirection, something between me or where I want to go. They did not add methods like map, filter, and reduce to collections. Instead, they created streams, and then they put the methods on stream. In Groovy and Kotlin, they did both. They added the methods directly to the collections. The solution exists. Yeah, that's a good one too. At any rate, they added the methods to the collections, and then they're eager. But in Java, you have streams which are lazy. In Kotlin, you have sequences which are lazy. What do you do in Groovy? Groovy just says, just use Java streams. So for example, just to show you what I mean, if I look at the lazy streams in Groovy, you see, this is doing a range with a collect. Remember, that's a map. Double them all, and then find the first one that's divisible by 3. See, that's a nice, simple method here. I got to get rid of that warning, which just says all these could be static, but they're fine. And here I could print them out as they go by. But if I want to use streams, I just say int stream dot range close. In other words, just write the Java code. And wherever the Groovy code expects a closure, provide a Java. Well, let me say that differently. Wherever the Java code expects a lambda, use a Groovy closure that has the same properties. And that works just fine. Okay, so again, Kotlin has as sequence, and they do both reduce and fold depending on whether you provide that initial argument of the identity value to the reduce method or not. If you do provide the initial argument, I think they call it reduce. And if you don't, it's called fold, unless I have that backwards. But it's the same idea. So they are just like Java streams, and there's some examples if you want to see it, but I'm going to move on. Okay, now, actually, here's the code that'll show you. So here in Java, I took my numbers, I make them a stream, and I go filter and map and then reduce, unless I did this, map to int, which would convert it to an int stream, and then I have a sum method. So here, it really matters whether it's an int stream or a regular stream. If it's a regular stream, I use the reduce method, and here's that identity value inside there. Whereas I could do map to int, and I could take advantage of an int stream having a sum method. In Groovy, I don't know whether they're ints or not, or rather the API doesn't care. So here I'll do find all, and there's the collect, again with the unfortunate name, and the inject. But I could just write sum and just rely on the fact I know they are ints, and therefore this will work. See, that's the essence of duck typing, is I didn't have to check. Now, this is the Spider-Man corollary applies. With great power comes great responsibility. If I'm going to do sum here, I better write a test case. You know what I mean? I've got to make sure these things work, because Groovy is so flexible that you can hurt yourself if you're not careful. But if you are careful, wow, it saves you a lot of time and effort. Okay, in Kotlin, it's back to filter and map. And you see, yeah, it's fold. I'm sorry, I got to set it backwards. Fold is the one with the extra argument. Reduce doesn't have it. Now, notice the same convention in both Kotlin and Groovy. Fold here actually takes two arguments. It takes the integer and a lambda. But the convention in both Groovy and Kotlin is if a lambda is the last argument to your method, you could put it outside the parentheses. And in fact, IntelliJ will say, hey, you didn't put it outside your parentheses. You want me to fix it. I mean, it's just an idiom. It's just a warning. You don't have to do it, but they do that. So at any rate, there's that. And then here's the sum method, which I got away with. I'm not sure why. Now, again, notice the it variable being used for a one argument closure with no named argument for the one argument. So that's basic map, filter, reduce in all three languages. Sequence, again, all that does is throw an as sequence on here, and now every element goes through the entire pipeline until it goes, and then processes the next element. So we process element by element, and we need a terminal operation, and we have one here. So the data is all processed, just like Java streams. Okay, I'm going to skip the POJOs versus POGOs part, other than to say that in Java, we now have records, but records are not quite what I think everybody was expecting a POJO to be, because they're final and they don't have default constructors and they don't have getter methods to follow the naming convention. In other words, they're not as useful right now as they might have been, but they are immutable and they are final. So there's pros and cons with the records, and we just have to wait for people to move up to Java 17 so they can use records, because they were final in Java 16, I believe. Very nice stuff. Now, Groovy, on the other hand, has POGOs, plain old Groovy objects. And the idea is if you throw this annotation on the class, this is what's called an AST transformation, abstract syntax tree transformation. It generates a toString, an equals, a hash code method, a tuple constructor, all for you in the bytecodes. This is not runtime. This is compile time programming. And, oh, hey, Bill. Yep, tuples there, right. A tuple constructor, however you want to pronounce it, tuple, I don't know. At any rate, this one annotation will let you write 3 or 4 lines and have a complete implementation of a POGO. I have an example with the golfers and everything, and you could take a look at it inside there, which does sorting and stuff. If we have time at the end, I'll come back to it. Right. Yes, thank you. As Jake pointed out, that Kotlin allows you to access the sum function due to type inference. It does. The thing is the type inference must work at compile time. Everything in Kotlin is compile time evaluated. All right, that's static binding by default too. You can't override anything unless it's marked open. You can't extend a class unless it's marked open. It's back to the old C++ approach rather than Java, which says you can override anything you want unless it's marked final. So it's a very different approach, interestingly enough. Oh, I see. So you're saying records are like tuples. And yeah, you could argue that. Sure. And by the way, what I'm waiting for is all the JSON parsers to figure out records. Now, the Jackson one, the one used by Spring, by the way, the Jackson one does understand records. But I've used JSON, I've used Moshi. They don't understand records yet. I mean, there's no default constructor. There's no getter setter methods with the same naming convention. There's no setter methods at all. You have to go through the constructor. It's not like they can't fix them, but most of them have not updated the libraries to work with records yet. Kotlin has something called a data class. So this really is like a Groovy POGO. You just declare the class, and it looks like a record. It just doesn't have the braces at the end. So this is the class that has a name and an email. These val keywords mean that these are final. Once they're set, they can't be changed. And the word data here means you'll get getters and, well, no setters in this one, but you would if you had var types. ToString, equals, hash code, copy method, and component end method used for destructuring, which is an interesting concept that Java doesn't have yet, but I suspect is coming. Canonical, similar to Lombok data annotation. Yeah, very much like. There's some slight differences, but that's a very good analogy, right? They are very much like Lombok data annotations. Now, let's go beyond that, okay? And by the way, I do promise at the end of this talk, there will be cat pictures. So you've got that to look forward to. At least I hope there's cat pictures. We're going to see. I'm going to access a RESTful web service. in parallel, no less, and render images from it. And boy, I hope there are cats, but we'll see. Okay, so here are some, quote, advanced. I mean, where do you draw the dividing line between basic functionality and advanced functional programming? I don't know. But here are some features that most functional programmers would consider important that are not in Java and are only sort of in Kotlin, but are in Groovy, interestingly enough. Closure composition is the mechanism of assembling closures with other closures, or lambdas with other lambdas. Now, Java has that to a degree. We'll see it in a minute, but not free form like Groovy has it. Memoization, tail recursion, and then currying as well. So let me actually go through it. So let me show you closure composition. When Java added functional features, they added a package called java.util.functional, and in there, they added specific categories of functional interfaces: consumers, predicates, suppliers, and functions. And those interfaces have combiners. So if I look at combined lambdas, here I've made a logger using Java util logger. Don't worry about log4j here. I did check my repo. I do not have log4j in any transitive dependency in my repository. At any rate, this I made a list of strings with nulls in it. And here's a predicate that I'm calling a null filter. It's referencing the non-null method in the objects class, which returns true if the object is non-null and false otherwise. This method exists to be used as a predicate: filter objects : non-null. That's why it's there. And then here's a predicate to determine if a value is even. So for each s, if the length of the string mod2 is 0, then it's even length, is what I mean by evens here. So I also made two consumers: the info method on that logger and standard print line. And then here's what we would call in other languages closure composition, or maybe we just call it function composition. The filter method takes a predicate. Well, one of the methods on predicate is and takes a predicate and returns a new predicate that returns a composed predicate that represents a short-circuiting logical and of this with the other. And then here, and then is in the consumer interface, which does a composed consumer that does the current operation followed by the argument, the after operation. So this logs it and then prints it. So this works. You know, I mean, here, if I run it, this is the closure composition in Java. You can see there's the even length words. And then here are the logger followed by the printer, or the printer followed by the logger. At any rate, it's all in there. Okay, they're all coming out there. The problem is you can only combine predicates with predicates and consumers with consumers and functions with functions. You can't combine an arbitrary lambda with another arbitrary lambda. I mean, you could try to write the methods yourself, so the output of one type of lambda goes into another, but you got to define the functional interfaces to make it happen. It's really hard to make that abstract. Whereas in Groovy, here's composition.groovy. Groovy uses the right shift operator. Well, that's the left shift operator. Here's the right shift operator. And then I could make a combined closure by saying the result of times 2 goes into the argument of add 3. And now I have a method like this. See, I'm able to combine arbitrary closures as long as the output of one fits the inputs of the other. And that's a feature that Java just doesn't have, and neither does Kotlin. And again, part of the reason I could do this is dynamic typing, is that I don't care what the details of the closure are. I just know they're closures, and then I could worry about the arguments inside. See, this is using the left shift operator to do the closure composition. This is just doing them in the other order to show you could go the other way, or you could use parens here and invoke them all. So this is a feature that Groovy has that the other two don't. They have to add extra mechanisms to do it. Kotlin has something that I took directly out of the Kotlin documentation. this said, okay, from the reference docs, let's make our own compose function with 3 generic types, A, B, and C. So the first function maps a B to a C, and G maps an A to a B, and the output should map an A to a C by saying, here's a closure for X, go F of G of X. And like, wow, good luck writing that on your own. Here is a length function, here is an is odd function, so I could do compose of is odd with length to get the odd lengths. And here's some strings, and I could filter them by odd length and also print them. And then they come out. Those are the strings with the odd length. But wow, I mean, you got to jump through the hoops to do closure composition, or I guess here they would call it function composition yourself. And when you say it looks like bind in Haskell, yeah, I'm not at all surprised. I mean, all of these language developers follow each other. They all know what the other languages are doing. It's just interesting. Now, will Kotlin eventually add that sort of stuff? I don't know. I mean, you see, you could do it. You just have to write it. It's a bit more work. Okay, now, what about tail recursion? And the other one is, it's the memoized part. So for this, I want to show you annotated functions in Groovy, and I think also in, I think I got a Kotlin one as well. So let me close all these. Got too many open. So this is in Groovy. Now let me show you the memoized one first, because this is very interesting. Here's a Fibonacci function implemented using recursion. Now, if you've ever studied recursion at all, you know this is a combinatorial explosion in the number of calls. So if fib of 5 is equal to fib of 4 plus fib of 3, then of course fib of 4 is equal to fib of 3 plus fib of 2, etc. You wind up doing tons and tons of repeated calls. And if you wind up doing Fibonacci of, 50 or something, then it just takes forever if it even doesn't give you a Stack Overflow. The memoized annotation creates a cache for the results of the execution. Now, this should only be used on a pure function. A pure function, again, returns the same output for the same inputs. So like they're showing here, if I have a sum function with 2 integers, shouldn't really be doing a side effect, but okay, that returns the sum of them, this one will make a map of the callers with the results. So that if I invoke fib of 5 and it has a fib of 4 in the cache, it'll just return the one from the cache. And basically this streamlines it. Now I could do Fibonacci of several thousand without any kind of problem at all. The memoized AST transformation builds the cache for you and works with it. You just have to make sure that you are doing a pure function here, so that if n is 0, it's 0. If it's 1, it's 1. And of course, then the joke, the gag is, hey, I've heard that this year's Fibonacci conference is going to be as good as the last two combined, right? Yeah, I'm sorry. They also show a memoized and a factorial calculation. And then here, by the way, is another AST transformation for tail recursion. So the idea with tail recursion, it's another functional mechanism where your pure function calls itself last. It has to be last, and it modifies the arguments. Now, here I'm taking advantage of something in Groovy that Kotlin also has, which is default values for the arguments. So this factorial says, I'm going to call factorial on a number, a big integer, and I've got this accumulator here that'll start off at 1. Now, G means big integer. And what I'm going to do is say, if n's less than 2, then return the accumulator. Otherwise, call factorial on n minus 1, and then multiply n times the accumulator. See, so that becomes the increasing accumulator is accumulating the values of factorial. This tail recursive. Now, here's the thing. You could write this code in Java, but it won't reuse the stack frames of the subsequent factorial calls. So it could compile if you write code like this, but it won't optimize. It won't reuse stack frames from previous editions. I mean, this one's saying you could replace the current factorial with the new factorial value. But with this tail recursive AST transformation in Groovy, I can do factorial of tens of thousands, and it happens almost instantly. And again, this to me is the mark of a more mature language. It's had time to develop stuff like this. Kotlin doesn't have this, and Java hadn't even thought about doing this, as far as I know. Okay. Yeah, you like the Fibonacci joke. Well, me too. Now, What Kotlin did do, and I'll mention this because I just want to show you this. I'm not using this in my repository, but they did make a library specifically for functional programming called Arrow in Kotlin. And that is how you can actually move along to things like monoids and monads and all that other stuff that is even beyond the scope of what I'm talking about. Now, the Arrow library consists of, well, here, let me show you real quick here. So let me copy that link address and let's open it here. You know, they have all kinds of functions. I don't see the obvious one. Yeah, all right. At any rate, oh yeah, that's right. Right. They have like a type called either and a type called validated, and they have, you know, composition and all kinds of different stuff in there. Feel free to take a look. I think there's a book from Manning called is it Functional Programming in Kotlin or something like that, and they go through the Arrow library. So I will acknowledge that that exists as well. Okay, now for Groovy, every Java library you have, you could just add to a Groovy program and use it just right out of the box. So, pardon me. So you don't have to wait for a library to be ported to Groovy or anything like that. That's why Spring can use Groovy right out the right off the bat, no problem. Now, there's a couple of things that are not exactly a result of the functional programming, but just to mention, because they do use these lambdas and receivers and everything, is that you could do meta programming. And I showed you already the isPrime method on integer in Kotlin. Well, in Groovy, you can do runtime meta programming. And what this is doing is taking the string class, and in Groovy, every class has a meta class, and I'm going to add a pirate function. I read out my key. I'm going to this RESTful web service, fun translations, and I'm going to say, okay, this is the base URL. And then I have to say the text is, let's use Java's URL encoder to encode the string under UTF-8 and then throw in my API key, convert that to a URL, get the text off of it, and use my JSON slurper to parse it, and then write this out. So this is adding a pirate method to string with no arguments. See, it's a 0 argument lambda, or closure, I guess I should say. And here I'm going to run it on hello world. How are you today? Please fill out your session evals, and I'd like to add you to my professional network on LinkedIn. And you can see, there you go. How be ye today? I'd like to add ye to me professional network on LinkedIn, our baby, you know. So you can do meta programming. This is runtime meta programming in Groovy. The AST transformations are a bit more popular because they are compiled, they are type safe, all of that. But I wanted to show you that that can be done. In Kotlin, I showed you the primes one. Here's a palindrome one, by the way. Palindrome. The idea here, now you see, this is the difference between writing Kotlin as though it was Java and using the Kotlin idioms. See, this is Java, just happens to be using Kotlin libraries. I take a string, I convert it to lowercase, I replace the non-word characters as a regular expression with an empty string, and then I check that the string is the same as the reversed one. Equals equals here uses the dot equals method. It's got operator overloading. So that's actually a dot equals test. This is a raw string. The triple quotes mean that you don't have to escape the escapes. You don't have to backslash the backslashes. I thought I saw a comment, and then I seem to have gone away. Must have missed it there. Again, I'm trying to keep an eye on them. So yeah, I'll get back to the debugging part in a minute. Any rate, here, on the other hand, is what I would consider more idiomatic Kotlin. Now, whether you want to add the method to the string class or not, that's a different issue. But here I did. And then again, I convert it to lowercase. I replace the non-word regular expressions with empty string. And then Kotlin has these things called scope functions, which are applied to any object ever. The let function, for example, says once we have something, let's do what's in the lambda. So it is the string after it has been lowercased and replaced. Say, let's check it versus the reversed, and that Boolean will be returned here. And then I have a test case, the palindrome test here. So there's some palindromes like a Santa pets rats as Pat taps the star step at NASA. This one down here is 543 words long as a palindrome. That is, in fact, a palindrome. And I also have a check to say, yeah, I'm not just returning true here. You know, I did make sure that's okay. But you see how now I can call is palindrome directly on strings and get the answers that way. Okay, now I mentioned I was going to show some cat pictures. Let me do that, and then I'll see if I can hang out for a few minutes if there are any questions. The debugging part, Java has a method in the stream class called Peek, P-E-E-K, which will allow you to put a consumer like print line, and it will let you print each value as it goes by. It's like the value comes in, it consumes it, but then it returns it again, so you keep going. It's a debugging mechanism that's built into the API. All of the major IDEs allow you to put breakpoints in a Lambda, but yeah, okay, that could be good or bad. There's a lot of layers of indirection there. Another mechanism I use for debugging is instead of writing out a full Lambda, I may make a method and then use a method reference in my pipeline. So because when I have a method, I can write test cases, and that'll help me because I can debug the individual Lambda that way as a method. That way, it's another option. Okay, now let me show you the cat pictures demo. Now, this is using a service from, you remember Flickr? Remember there used to be a service called Flickr? At any rate, Flickr has an API, and those people who are RESTful web services advocates, the ones actually call themselves Restafarians, believe it or not, they would be appalled because this actually tells you to put the method you're calling in the URL, which of course violates so many levels of the Richardson maturity model. You know how it is. Yeah, don't rely too much on Peek. Well, I don't know. I mean, it's there for debugging. Just I put it in, I debug, I take it out again, you know. But what I'm going to do is I'm going to access this. I'm going to parse the JSON data, and that will give me links to 6 images that I also have to download. I'm going to use Java parallel streams to download the images simultaneously. And then I'm going to use Groovy's Swing Builder to have a little DSL to generate the images and the output here. I got to tell you, though, I don't know what images I'm going to get because, I mean, it's whatever the latest 6 images in Flickr are that's tagged with the thing I'm using. So, you know, be kind. The good news is it's going to show up on my other screen rather than this one. So if it's truly horrible, I'll just close it. So catpictures.groovy. All right, starting at the top here, by the way, one of the things you could do in Groovy that's kind of neat is you can alias imports. So instead of having to say window constants dot something, I could just call it WC. Now, this is a script. It's not in a class. It's all just top level. Here's the endpoint I'm going to, their REST endpoint at Flickr. And I'm going to do, this is a Groovy map. As they say here, it's actually a linked hash map, but I don't care. It's just a map. And Groovy maps go key, colon, value, and the keys are assumed to be strings, so I don't have to put quotes around them. So I'm doing the Flickr photo search. The API key is saved in a file on my in the repository, so be kind, you know, called flickrkey.txt. And then the .text property invokes the getText method. This is a method that Groovy has added to file so that I could read the text out of it. So I grab the key. I want JSON data. I'm going to search for kitties. That's been the most successful. If I search for cat, sometimes I've gotten tractors, you know, caterpillar. Sometimes I've got dogs. I've gotten monkeys. You just never know. So kitties seems to be pretty reliable. I'm going to ask for photos. I just want 6 of them. Okay, so we'll see the 6 here. All right, so this again is map. So take this params. This is a map. And I will collect each entry because the toString method on entry is key equals value and join them with an ampersand. So the overall URL is this endpoint followed by the query string, which will be method equals this and API key equals that and format equals. That'll build it all up, convert it to a URL, and then get the text there. I'll write it to a file called cats.json. If the file exists, I'll delete it. I'll pretty print it to the console so you can see the JSON data all out there. But now I'm going to go use that JSON slurper, you know, to parse it. And I'm going to drill down inside the JSON data. There's a child element called photos, which has a child element called photo. There should be 6 photo elements. Okay. In fact, to see this, let me show you right here. Here's the last time I did it. this is what the JSON looks like. Photos, and then you have a photo element with all these different elements in it, and I actually have 6 of those. Okay, so drill down to the photos. Now, down here, I'm going to take those photos. I'm going to make a Java parallel stream. I already changed it to parallel stream. And in each one of those, I'm going to go to this method here, photo to image, where I'm going to print out the name of the thread and the title. And then this is the URL pattern that Flickr provides me for downloading the actual image. So I'll read that using image.io, and now I will have an image. So this is going to try to download all 6 images in separate threads and then load them into a list of images. This is the builder. So I'd make a Swing builder, and on the event dispatch thread, I'm going to make a JFrame whose title is cat pictures, visible is true. By the way, the 2 people, the earlier speakers who talk about JavaFX, I really need to port this to JavaFX, I know. But at any rate, this is Swing. There's my title. I'm going to pack them. I'm going to use a grid layout with 3 rows and 2 columns. The default close operation is exit on close. And for each image, I'm going to make a JLabel with an image icon that has the image in it. All right, keep your fingers crossed. Let me run this. You'll see it spit out. See, there's all the worker threads that it's using. And yep, nothing too awful, nothing too great either, but this is what I got. Yeah, cat. I think there's a cat in there. Sort of a cat. You know, I didn't get any. Oh, there's one actual cat. Okay, I'm putting that in the win column. You know, I'm calling that success. And that allowed me to use Groovy with Java parallel streams and do all that. There's the titles, there's the threads and everything. I didn't get to stick Kotlin in there. Maybe I should redo that with coroutines and see what that looks like too. But I haven't done that yet. So to summarize, you can use Groovy and Java and Kotlin together. I'm doing them all in the same GitHub repository. It works fine. Java's functional capabilities are there. They're kind of limited. They're streams, lambdas, method references, map, filter, reduce. That's kind of it. Groovy goes way beyond that. I didn't even get to things like traits. You can also do currying in Groovy. You can make a new closure from an existing closure by plugging in values. You know, there's a lot of stuff you could do. I didn't even get to that. Kotlin has some of these features, but not all. Again, I consider this a symptom of being relatively young relative to the others. It may add more as we go along. And that's everything. Again, there's the GitHub repository. I'm looking at the comments here. JavaFX has been removed, but Swing remained. People are still using it. I don't know. I'm using the builder, and the builder works for me on really simple apps. I'm not an effective desktop Java or desktop Groovy person. If I was, I would learn JavaFX, and it's in my list of things to get to someday. Any other questions, comments, words of wisdom? Heard any good jokes lately? I mean, I've already thrown out a bunch of my bad ones, you know, that are really awful.
I like the jokes.
Oh, well, you're all right, man. Thank you. I appreciate that. Oh, thank you for pointing out when that talk is on JavaFX. That's right. It's Paul and Gail Anderson. They know the JavaFX stuff. So if you're interested in desktop Java at all, go see their talk, definitely.
So Ken, you're real quick. Yes. I wake you up in the middle of the night and I grab you and I say, quick, in the next couple of seconds, tell me which language you want to use.
And it's Groovy.
What is it?
Yeah, it is. I've learned Kotlin and I'm happy with it. And by the way, the Java features up through 17 make it actually much more fun to use. I really like it now, much better than I did. But Groovy's kind of my first love. So
there you go. There you go. What other questions do we have here?
Yeah. I don't see anything else that I haven't at least addressed. Do you believe it? I actually fit this in the hour, you know?
And we're coming right up to the minute now. So not just,
I'm calling that a win. By the way, just for the record, let me say I've only changed the cats JSON element. So I'll add that and commit with the add new cats.json and push. And now everything's in the GitHub repository except these slightly updated slides. But, you know, again, feel free to keep in touch. You know, here's my contact information again. You know, love to hear how you're using any of them. Scala, I don't know. And Clojure looks wonderful. Looks like a really cool language. I just haven't had the time to get into it. I've been very impressed with the Clojure people I've met. And if you like Lisp, Clojure's a Lisp on the JVM. I wish I had time to dig into it. I don't really have a use case for Scala at the moment. I could do most everything I want to do in Scala. I could do in either Groovy or Kotlin. So, I mean, maybe that's just me. Oh, yeah, this is the last talk of the day. So we're kind of okay.
Oh, boy.
Yeah. So if there are any other questions,
we'll keep an eye on there's a delay. So we'll keep an eye on the chat for a minute here.
Oh, the use case on traits, by the way, take a look at Grails. Grails took a lot of their object relational mapping mechanism and implemented them as traits. So again, it's a lot like doing Java interfaces with default methods in them, and you're able to apply those methods to objects. So they used to do it all in Grails used GORM, Grails object relational mapping. It used to be all as runtime metaprogramming. And then they redid it as traits at compile time and got substantial performance improvements. So if you're looking for a use case for traits, that's the place I'd go that I really am impressed with. Grails is still a thing, by the way. It's still growing and improving. And by the way, the Micronaut framework is created by a lot of the same people. And that's, if I just wanted microservices, I go look at Micronaut. And they also use GORM, incidentally. So that's available in either. Okay.
Ken, I have one more question, one more burning general question. Are there situations where you would avoid using the functional paradigm, even though it's available to solve the problem?
Nothing jumps to mind, although I would say this. I don't go and rewrite old code unless I have a reason beyond, hey, let's make it functional. You know what I mean? If I have working code and I have test cases, I'm happy with it. So I don't generally update everything to be functional. Also, functional, like if I have to process the same set of data multiple times, in Java, you got to do the stream over and over and over again. Every time you close the stream, you got to recreate it. So that feels a little inefficient sometimes. If I can't restructure the code so that I do all the things I need to do in one pass, then, okay, loops still work. It's not like they're gone, and the performance is fine either way. Does that help?
Yeah. Yeah, thank you. Any other questions on the... I don't see anything. So I guess what I want to do is thank everybody for attending. Attend more of the conference tomorrow.
Right.
Enjoy the J Champions conference, and we'll see you soon. Thank you, Ken.
Good to see everybody. Thank you so much. Sorry, didn't mean to interrupt.
Nope. Thank you. Thank you. Thank you.
Bye-bye.